Hey guys, Mr. Middleton here. Today we're going to look at segments, rays, parallel lines, and planes. So at the end of this video, you should be able to name and define segments and rays, and you should be able to differentiate the differing types of non-intersecting lines and planes. So we'll start with the definition, and the first definition we'll talk about is segment. A segment is a line, is a part of a line consisting of two endpoints and all of the points in between them. So it says name all the segments on line K below. So as we look at this, and I'm going to scroll up so we can see it a little bit more. So as we look at this, then we can name these segments and say, okay, remember that a line continues on forever and ever and ever and ever. A segment just says, hey, it doesn't continue on forever. We have endpoints. And so we have the segment FG. We'd also have the segment GH. And you might say, hey, these are segments too. We don't have another point to name it. So we won't call it like H something or F something, right? And remember that we won't say GF. That's not a new way to name FG. It's just redundant. Okay, so we have segment FG, we have segment GH, okay, we have segment FH. Okay, so how many points are on FH? There are an infinity amount of points. Remember that a line is it consists of just a bunch of points, a bunch of points, a bunch of points, and there's no size to points, so a bunch. But there are three named points. We can say there are three named points on FH. Okay, let's define something else. A ray is a part of a line consisting of one endpoint and all the points of the line on one side of that endpoint. Okay. Two, let's see, opposite rays are two collinear rays with the same endpoint. These always form a line. Use the figure below to answer the questions. So let's get to it. It says name one ray with endpoint C. Okay, so when we name a ray with endpoint C, remember that means that's where it ends, and then we look at the diagram over here. I can name one that says like ray CF. Okay, and it's important that no matter the direction of the ray, you always start by naming it with the endpoint. So C is the endpoint, F is the direction that it goes in, and I'm going to name it like this. Notice the notation tells us, hey, it's C is the endpoint, it goes in the direction of F. All right, next question says, are BD and BC the same ray? And so when we look at it, just the name of it, we're like, no, one's BD and one's BC. But remember, we look at the definition, we say it's the endpoint and every point in the line in the direction of the other point. So BC seems like it stops here, like as we think of it, but it continues on forever. That's what this arrow means. And so as it continues on forever, we are going to continue on through D and all the other things that are on this line. So are B, D, and BC the same ray? Yeah, they are. Direction, abbreviated. All right, so next question. Are AB and BA the same ray? Take a second and try to answer that. So this one's a little bit, hopefully, easier at the beginning because there's a big difference in the way we start. Remember that BD and BC were the same because they, or at least had the potential to be the same because they had the same endpoint. AB and BA do not have the same endpoint. Okay, so AB says from here and everything in this direction, and BA says from here and everything in this direction. So no, they are not the same ray. They don't have the same endpoint. Next, it says are CD, ray CD, and ray DB opposite rays? Our endpoints should We shouldn't have to have a diagram here to answer this question. At least later on, we will not have to have one. But without a diagram, and we're going to reference the diagram in just a second, the endpoints are the same. Remember that opposite rays have the same endpoints and went in opposite directions and made a line. Okay, CD and DB don't have the same endpoint. So even as we look at this, CD and then DB, even as we look at this and we're like, hey, but it does make a line, they don't have the same endpoint. So they are not opposite rays. Okay, so there's two things. They have to make a line and they have to have the same endpoint. And then number 5, it says ray CB and ray CF are opposite rays. So are they? Let's look. CB, CF. So at least with this, we needed the diagram because we were like, well, has the same endpoint, could be opposite rays. But as we look at it, CB over here, CF over here, do they make a line? No. They don't. Okay, let's talk about intersecting lines and non-intersecting lines, I guess. There are 2 types of lines that don't intersect. The difference lies in whether or not the lines are in the same plane. So the most of the time when we talk about lines that don't intersect, we're familiar with parallel. Parallel lines are coplanar lines. They lie on the same plane that do not intersect. Skew lines are non-coplanar lines. Okay, we talked about these words last section. Non-coplanar lines that do not intersect. So most of you probably already know about parallel lines, but skew lines are something new for a lot of people. At least the term is new. It's not new if you've driven anywhere really. But to visualize this, we'll use Interstate 69 and Illinois Road. So when we looked at when you drive on Illinois Road, there's a few lanes, but I'm just going to say there's one, right? And you can go this direction on it. And then over here, you can go this direction. And these streets or these lanes are parallel. So the cars that use here will never run into each other, right? Well, I-69 goes over that, right? Because you go under the tunnel. But now these lines are going over, and I'll try to keep it here. It's going over Illinois Road so that people can travel in another direction and still not run into each other. These are examples of skew lines. Okay, so the direction of the traffic and the traffic being on a lifted different plane will never intersect with Illinois Road unless the cars fall down and become on the same plane. Okay, so skew lines are lines that don't meet, but not because they are parallel, but because they do not share the same plane, skew. So parallel would be lines like this that don't touch. Skew would be lines like this that don't touch, but only because they do not share the same plane. Planes can also be non-intersecting. Planes. So we can have planes that do not intersect. They are called parallel planes. Parallel planes. There is no such thing as skew planes. Okay, there's not a way. If they don't touch, it's because they are parallel, not because they are skew. Obviously, if they're 2 different planes, there's never a possibility for them to be coplanar. Okay. So let's answer some questions. It says use the figure below to answer the following questions. Name all lines parallel to CB. Again, you can use your OneNote, your pen, marker, highlighter, whatever, to help answer these questions for you. They want us to name all the lines that are parallel to CB. So important for us to look at parallel and not just, hey, they don't touch, but they have the same direction about them. Okay, and so when we look at lines that are similar to BC, hopefully we were like, oh yeah, this one, EF. EF is going the same direction and it will never touch. Okay. EF is parallel to CB. We'll call it a segment because that's what it told us. Even though it says name the lines, I guess I should say lines, EF. Okay. When we look at the other lines that don't run into BC, like DE you look at that over there, like it doesn't run into it, but the direction is not the same, right? If it were over here, it would definitely, okay, it would definitely run into it. So you'll notice that ED, even though it doesn't run into BC, it doesn't look like the same line at all. And so this is an example of skew lines. They only don't run into each other because they do not share a plane. All right, next, name all planes parallel to AD, or all lines parallel to AD. So as we look at AD back here, we can say, okay, AD, what shares its plane and doesn't run into it? Well, BE, right? It shares a plane, ABE. And so those two don't run into each other. And as we look at those lines, they follow the same direction. So BE is an example of a parallel line or a line that's parallel to AD. And then also CF, notice that they share that bottom, don't run into each other. And I didn't call it CF, even though I said CF out loud. Number 3 says name a line skewed to BE. So again, it says a line. We don't have to name all the lines that are skewed to BE. But as we look at BE, goes up here, we're looking at a line that does not intersect with it, but it doesn't share a plane. So an example here would be AC. Again, as we draw this, it's kind of easy visually that, hey, they're not going the same direction. They must not meet just because they aren't on the same plane. So AC is an example. It's not the only example. I'm sure you could name others, such as DF and, is that it? That's the only one. Okay. Could also name DF. So describe the intersection of CF and ED. So if we're just describing the intersection of CF and ED, CF is down here, ED is over there. They don't intersect, actually, okay? But that's because the lines are skew. Those are skew lines. They're not parallel. They don't go the same direction. They don't intersect because they don't share a plane. Number 5 says name a pair of parallel planes. Name a pair of parallel planes. So as I'm looking at these parallel planes, I'm like, okay, what planes don't intersect? And most of them do. The only ones that I can see that don't intersect is this front triangle and the back triangle. Okay, and those planes I can name 3 non-collinear points, ABC and EDF. And number 6, it says, where do CFD and EBA intersect? CFD is the bottom. All right, CFD, bottom also includes A. And EBA, so EBA is the backside. So EBA, so the bottom and the backside, they intersect at line AD. And that's a little bit of a review. Remember, where 2 planes intersect, it's always a line. Let's do a little bit more, just a few more. Again, if you find it helpful, you can use your draw in OneNote, or if you have it printed, pencil calculator, highlighter, color pencil, whatever, finger, to highlight some of these things, just so it's a little bit more visual for you. Okay, because we are trying to discuss 3-dimensional things on a 2-dimensional surface. Okay, so here we go. Name the plane parallel to JAG. So with all these questions, it's very important for you to understand what's being named. So when we say JAG, we're talking about this, I'll call it the left side of this prism. So JAG, we need to name a plane that's parallel to it. And that plane that's going to be parallel to it is going to be on the other side over here. So we can call it BCI or IHB, something like that. Name all lines parallel to BC. So all the lines parallel to BC. So as we look at BC, it goes vertical up here. So we're looking for things that are parallel because it goes the same direction. So it's a little bit tricky because there's one that we might miss. But AD is parallel, right? HI is parallel. Those are 2 that we would not miss. The one that's typically missed here is GJ. And that's typically missed because you're like, well, what plane does it share? Remember that the walls and the floors are planes, but those are not the only planes. They're just the most visual for us. There's also a plane here, right? Like we kind of did at the end of last notes, where it's like a piece of paper that goes through here. All the lines that are parallel to BC would be AD, GJ, and HI. I should name them lines, but I'll follow their notation and do just that. Okay, it says name all skew lines, all lines skew to BC. So again, we're looking at BC, and we're looking for lines that do not intersect it, but only because they don't share the same plane. And there's a lot of them, right? So like DJ won't ever run into it. AG won't ever run into it. GH won't ever run into it. JI. Now, as I draw it, you might be like, well, doesn't it run into it? Remember that there's some depth here. That's what the dotted things are for. Some depth here that won't run into it. AB runs into it. BH runs into it. There are other things. So I know that, especially paper pencil test people are like, well, DG's a line that doesn't run into it, and AJ's a line, and HJ and GI. So I should probably edit these notes and say all drawn lines that are skew to BC. Okay, and so we have 1, 2, 3, 4 skew lines that to BC that are drawn. So AC, JD, GH, and JI. All those lines, make sure I call them lines. And then it says name all lines parallel to GHA. So here they're saying lines parallel, and then they give us a plane. So important for us to realize that GHA, though, is talking about the top of this GHA is talking about the top of this prism. So when we say lines that are parallel, we're talking about lines that don't intersect with it. Okay, so when we look at that, we say, okay, DJ won't intersect with it. Remember, you cannot be skew to a plane. JI will not intersect with it. C, what is that letter? I'll erase it later. I think it's I, CI, and BC. So we have 4 lines that are parallel to the top, cannot be skewed with the plane. Okay. So all those would be DJ, JI, DC, CI. If you wanted to get fancy, you could say JC. So there you go. You should know rays and segments, and you should be able to differentiate between skewed lines and parallel lines. And we did a little more practice identifying those things. See ya.